Hey YouTube, vSecure here. Today I want to talk about creating a switched virtual interface, or SVIs. Now in the last video I discussed creating a router on a stick where a router routes the traffic between the switched environment. Now the other option is to create these gateways on the layer 3 switch themselves. This will allow the switch to become the gateway and route any locally connected networks. To create a gateway on a switch is called creating a SVI, the switch virtual interface. Now this is my environment where I have a computer on one VLAN, VLAN 10, and another computer on VLAN 20. So we can show that right now one computer can't talk to the other. So here's the IP on one and the IP on the other. Alright, so let's try pinging the second computer. And as we can see, it's going to fail. So let's create that SVI. So on our switch, we are going to go into global config mode and type in interface VLAN and then the VLAN number we chose. And in my case, it's VLAN 10. This creates the SVI. Now we need to assign an IP address to this SVI. And this is the same command that's used on the router. It's IP address. I'm going to do 10.10.10.1 and then the subnet. And also in my case, on some switches, you might have to no-shut the VLAN. And now, some things to make sure are done prior to creating this layer 3 SVI is to make sure that the layer 2 VLAN is created with the VLAN X command, the number on that VLAN. If the SVI is created, but the layer 2 VLAN hasn't been created, then the VLAN will never come up and traffic will just be black holed. Now I'm going to quickly create VLAN 20s. And no shut it. And now to show that it's working, we're going to hop on this computer and ping the gateway. Now you'll note the first ping failed, and this is common when a device has to ARP for the MAC address to get the IP, or to MAC for the ARP for the MAC address from the IP. So after that, we can see the pings work and we can reach the gateway. Now the configuration is complete. A couple commands that can be used to verify that IPs are assigned on the router is the show IP interface brief exclude unassigned, and there's our two IPs on our layer 3 SVIs. Now one note, on some switches you might have to turn on IP routing. I believe now it's mostly common, but if it's not, I'm going to turn it off. What will happen is you won't be able to ping between the VLANs. So if I now try pinging the other switch, or the other endpoint, I just time out. So we have to enable IP routing. One thing you'll notice too is if I do show IP route, there's nothing here. So let's turn on IP routing. And now we can run that same command, show IP route. And now we can see we have these locally connected VLANs. So let me now try pinging the other device. And as you can see, it is now coming up, and we can ping. And we know it's going to work, but we'll do it anyway. We'll ping from the second computer to the first. And again, it's coming up. Now, one thing to note, if we look at the previous video, some of the latencies from the PC going to the router and then to the other PC, they're generally going to be higher than what you'd see on a layer 3 SVI. And part of that reason is because you are doing another extra hop. You're going from the switch to the router and then back to the switch. So you're going to add a little bit of latency. So you might actually improve performance if you move your gateways to your SVIs, to your layer 3 switches. But that's it. Now we know how to route traffic between VLANs on switches using either router on a stick or by creating this SVI. Now in the next video, what we'll do is we'll review routing between two routed switches using a routed interface. Thanks everyone.